Greetings, everybody, and welcome to example 4 of cross products. So here we're asked to compute the cross product I cross j cross I, in which we have no parentheses. Now, one problem that we have in this situation is that the cross product is not associative. And so what that really means is kind of hearkening back to maybe our days in beginning algebra when we had things like addition and multiplication. Well, we could have the associative property of addition, which said it really didn't matter which one that we did first. We could add A and B first and then add C, or we could add B and C first and then add A. The associative property told us that we were going to get the exact same answer either way. And we had the same thing for our usual multiplication. If we had A times B times C, then that was actually going to be equal to A times our B times C. So that for our usual notions of addition and multiplication, we had the associative property. In those cases, it did make sense then to write down some expression of the form A plus B plus C without parentheses, because it really didn't matter which one that we did first. Well, with cross products, it's a little bit different. We lose the associative property. And to see that's the case, consider the problem if we did the I cross J and then cross J with itself. Well, what we had there because we're doing the parentheses first, I cross J is going to give us K. And so then J cross K was going to give us a minus I. However, if we do associate the other two vectors first, so if we would do something like I cross our J cross K, in this case what would happen, J cross J is going to give us the 0 vector, because any vector crossed with itself gives us 0, and so I cross 0 is going to give us 0. And sure enough, we can see that we do not have that minus I is equal to 0. That's going to give us a big no. And so what that tells us then is we do not have the associative property for cross products. And so just writing something like I cross J cross I is really kind of bad form. What we should write in there, if we really wanted to do this kind of properly so that everything is clear and unambiguous, then we should probably put parentheses around those first two. In that case, what happens? We then have I cross J, which gives us K. And then if we then take K and cross that with I, we will have our vector back, J. And so if we were to include parentheses in that, then our answer would be J, assuming that we did the answer grouping the first two together. If we did our answer by grouping the last two together, then our J cross I is going to give us an I cross a minus K. We have a minus I cross K. And so the minus I cross K is going to give us a minus J. And so the minus of the minus still gives us an answer of J. So in this case, we do happen to get the same answer, but in general, that is not the case. And so we should not really just assume that we will get the same answer just grouping the first two together and then calculating the second. So I hope this problem has been insightful, kind of given you something to watch out for, that it really is kind of bad form to write the cross product of three vectors without grouping together which ones that you want to do first, because in general, you may not get the same answer. So I hope you've enjoyed this, and I will see you guys in the next problem. Take care.